let's talk about implicit differentiation. Now, implicit is just an English word. Its opposite is explicit. Now, in function terms, if a function is explicitly defined, then the dependent variable is made the subject. Normally, at this level, our functions have the dependent variable to be y. So if I write y is equal to 2x plus 1, then this is an explicit function. I can write y is equal to 2x squared plus 3x plus 6. This is an explicit function. I can write y is equal to x plus 1 over 2x plus 1. This is an explicit function because y has been made the subject. So realize that in all the differentiations we've been doing so far, y is made the subject, and those functions were explicit functions. Now, let's go to the implicit. If there is a function where y is not made the subject, the dependent variable y is not made the subject, then it is an implicit function. So for instance, implicit. If we have x squared plus y squared is equal to 9, here, neither x nor y has been made the subject in the function. So this is a kind of implicit function. So I can write another one. We can have 3x squared y plus maybe y is equal to 7. This is an implicit function. So when you have an implicit function, you have to differentiate it using the implicit differentiation approach. Now, how then do we differentiate an implicit function? So we have x squared plus y squared is equal to 9. In an implicit differentiation, remember, we are still looking for dy dx. Y here is still the dependent variable, and we are differentiating the function with respect to the independent variable x. In implicit differentiation, we differentiate all terms, including the dependent variable y. So it technically means we have to differentiate both sides of this equation. So you're going to write d of dx into bracket x squared plus y squared is equal to d dx of 9. D dx here means it is telling you to differentiate what is inside the bracket. It is just an operator telling you that differentiate what is inside the bracket. D dx of 9 means differentiate 9 with respect to x. Now, if you differentiate x squared, the result is 2x, as you already know. However, in implicit differentiation, anytime you differentiate a y term, you add or you multiply it by dy dx. And I'm going to prove that at this side. So let me rule this. I'm going to prove that here. So if I differentiate y squared, it is going to be 2y, and then I multiply this by dy dx. And then if you differentiate just 9 is a constant, the result is going to be 0. And then from here, we make dy dx the subject, and we end our differential. So it means I have to make dy dx the subject. So let me bring this one here. So that will be 2y dy dx is equal to negative 2x. Then when I divide both sides by 2y, I'll have dy dx is equal to negative 2x over 2y. And we can simplify further and have x negative x over y. So it means that in an implicit differentiation, you can still end up with your differential having y term, and it is fine. Now, I told you I will explain to you why we multiply the differential of a y term by dy dx. So the y squared there that we want to differentiate, is a dependent variable, which is in terms of x. Remember, y is the same as f of x. So y squared is going to be f of x all squared. Take note, in every function, y is the same as f of x. So if we are having y squared, then it's going to be f of x all squared. Now, we use the chain rule to differentiate this. And if you are going to use the chain rule, remember, you have to bring 2 down. You differentiate what is inside. If you differentiate f of x, it is f prime of x. So we have f prime of x. And then you subtract 1 from here. That will give you f of x all raised to the power 1. F of x raised to the power 1 is the same as f of x. Remember, f prime of x is the same as dy dx2. So I'm going to have 2 dot dy dx dot f of x, and f of x is y. So I'll have 2 dot dy dx times y, and in the end everything will be, if I bring this one here, to be 2y dy dx. So the reason why we multiply by dy dx whenever we differentiate a y term is because we are using the chain rule to differentiate the y term. But you don't have to go through this long process. All you have to put in your mind is that anytime you differentiate a y term, as we have here, you multiply by dy dx, and it is coming from the chain rule. So that is how you differentiate an implicit function. Now, let's talk about these 2 examples. So, starting from the first one. The first one is x cubed plus 2y minus y squared is equal to 5. So here, this is an x term. So we differentiate it. That is going to be 3x squared. Then this is a y term. If you differentiate 2y, the result is going to be 2. However, because it is a y term, we add dy dx. And by this, I believe you remember where it is coming from. The next term is also y squared. We differentiate negative y squared. That will give us 2y. And then because it is still a y term, we add dy dx, or we multiply by dy dx. And then the other side is 5. If you differentiate 5, the result is 0. Now, we need to make dy dx the subject. So it means we need to send this one here and factor dy dx out of these 2, because dy dx is here, dy dx is here. So I will have 2 dy dx minus 2y dy dx is equal to negative 3x squared. And then from here, I can factor dy dx out, leaving 2 minus 2y, which is equal to negative 3x squared. And I can divide both sides by 2 minus 2y. So I'll have dy dx to be equal to negative 3x squared, all divided by 2 minus 2y. And we are done with our differential. Now let's look at the second example. The second example is x cubed plus y cubed is equal to xy. We differentiate the x cubed, that will give us 3x squared, plus we differentiate y cubed, that will give us 3y squared. Then we multiply by dy dx. And then to the right hand side, we have a term which is xy, a multiplication. And then we must treat xy as a product and use the product rule to differentiate. Remember the product rule? In that case, it means this is going to be our u and this is going to be our v. In the product rule, we have u differentiated multiplied by v plus v differentiated multiplied by u. So it means if x is our u, we need to differentiate x and multiply by v. So that will give us, if you differentiate x, the result is 1. Then if you multiply by v, v is y. So that will give us 1 times y. And then in the second part of the product rule, we need to differentiate v. If we differentiate v, which is y, it is going to be 1. But because it is a y term we are differentiating, we need to add dy dx and also multiplied by our u, because it is v prime u is x, so we multiply by x. So if I'm going over again, it is xy and it is a product, and therefore we need to use the product rule. Our u is x, our v is y. We differentiate u, which is x, the result is going to be 1. We multiply by v, which is y. So that is done. Plus our v that we need to differentiate is y. So if you differentiate y, obviously it is 1. But because it is a y term, we are differentiating a y term, we need to multiply by dy dx. And then after that, we multiply by u, which is x. So we have x here. So if you are going to do a rearrangement, you are going to have 3x squared. So I think we should send all terms not involving y, not involving dy dx to one side, and all terms involving dy dx to one side. So we're going to have 3x squared. Let me bring this one here. Minus y is equal to, then this one is going to be x dy dx, and we bring this here. That will make it 3y squared dy dx. So we can write 3x squared minus y is equal to, and then we factor dy dx out. That will be x minus 3y squared dy dx. We divide both sides by x minus 3y squared. That will give us 3x squared y divided by x minus 3y squared is equal to dy dx. And therefore, dy dx is equal to 3x squared minus y divided by x minus 3y squared. So we are done with the differential. So here, the new twist is, whenever you have a term which is a product of x and y, you treat it as a product and use the product rule. That is it. So let's take some few other examples, about 2 of them, then we end it. Now let's take these 2 examples to end our implicit differentiation. So the first one is a x y squared minus x squared plus y is equal to 0. The first term is a product, and therefore we need to apply the product rule in dealing with it. So it means this is our u and this is our v. Remember the product rule? It is u prime v plus v prime u. So it means we first have to differentiate x. That will give us 1. And remember, if it is 1, you can even decide not to write it. And then we multiply by y squared, where y squared is our v. So we are applying this. Then plus our v prime. Our v prime is going to be 2y. Then because this is a y term, we multiply by dy dx. Then we multiply by our u is x. And then we are done with the differential of this. We come to this. That will give us 2x. Then we differentiate y. That will give us 1. Then we multiply by dy dx. and then we equate everything to 0. So we group like terms. So let's send this and that to the other side. So we have this is going to give us 2xy dy dx plus dy dx is equal to, send this here, that is equal to it's going to be 2x minus y squared. Then we factor dy dx out, so dy dx out 2xy plus 1 is equal to 2x minus y squared. Dy dx is equal to 2x minus y squared divided by 2xy plus 1. And we are done with our differential. So we are going to talk about the last one, which is B, to end implicit differentiation. So we have x cubed plus y cubed minus 6xy is equal to 0. Now we differentiate this one. That will be 3x squared plus, we differentiate this, that will be 3y squared. Because it's a y term, we have dy dx minus, here it is a product but it has a constant, so let's keep the constant out and differentiate x and y using the product rule. If you are going to differentiate x, y using the product rule, remember this is going to be our u, this is going to be our v. So we differentiate u, that will give us 1, and we multiply by y, so everything is going to be y. And then we differentiate v, that is also going to give us 1. Then we multiply by x, that's going to give us x. Then because the differential of y, this is a y term, we multiply by dy dx. And then we close it, and if you differentiate 0, it is still 0. So we have to expand this bracket, so that will give us 3x squared plus 3y squared dy dx minus 6y minus 6x dy dx is equal to 0. So we group like terms. Let's send this and that to the other side. So we're going to have 3y squared dy dx minus 6x dy dx is equal to 6y, then we bring this one here, minus 3x squared. And we factor dy dx out from here, so dy dx out 3y squared minus 6x is equal to 6y minus 3x squared. Then we divide both sides by this, so we have dy dx is equal to 6y minus 3x squared, all divided by 3y squared minus 6x. So this is the end of our differential, and this is the end of implicit differentiation.